For this video, we will be discussing some of the circle theorems: the perpendicular chord bisector theorem, angle in a semicircle theorem, and the inscribed quadrilateral theorem. Now, let's solve it. In a circle whose diameter is 20 centimeters, a chord is 8 centimeters from the center. How long is the chord? In our figure, we have the 20 centimeter diameter and the chord, which is 8 centimeters from the center. This bisector is perpendicular to the chord, which results to 90-degree angles. Note that the diameter is equal to twice the radius. Substitute our diameter 20. 20 is equal to 2r. Divided by 2 both sides. 20 divided by 2 is equal to 10. 2r divided by 2, cancel out the 2, is equal to r. Now, we have our radius, which is 10 centimeters. Notice that this forms a right triangle. Since our chord is bisected, it will be divided by 2. Applying the Pythagorean Theorem, c divided by 2 squared plus 8 squared is equal to 10 squared. Now, c divided by 2 squared plus 64 is equal to 100. Transpose 64 to the right side. C divided by 2 squared is equal to 100 minus 64. C divided by 2 squared is equal to 36. Take the square root of 36 to get c divided by 2. The square root of 36 is 6. So c divided by 2 is equal to 6. Now, let's transpose 2 to the right side. C is equal to 6 times 2. 6 times 2 is 12. So C is 12 centimeters. The length of the chord is 12 centimeters. In circle P, the diameter is 26 centimeters and the chord is 24 centimeters. What is the distance between the chord and the center of the circle? Here we have the circle and its center. This is the diameter, and next is the chord. Now we have the radius. We are looking for the distance between the chord and the center of the circle, which is h. Our given are D is 26 centimeters and C is 24 centimeters. Note that the diameter is twice the radius, so D is equal to 2r. Substitute 26 is equal to 2r. Divide 2 both sides, we will have 26 divided by 2 is equal to 2r divided by 2. 26 divided by 2 is 13. 2r divided by 2, we will have to cancel out the 2, which will be equal to r. So, our radius is 13. As you can see, our radius is 13. And h bisects C. So, we will have to divide our chord by 2. Chord divided by 2 is equal to 24 divided by 2 equals 12. So each side of the chord is 12. This forms a right triangle. And since we are looking for h, we could use the Pythagorean Theorem. 12 squared plus h squared is equal to 13 squared. So 144 plus h squared is equal to 169. Transpose 144 to the right side. H squared is equal to 169 minus 144. So h squared is equal to 25. To get h, we will have to get the square root of 25, which is equal to 5. So the answer is 5 centimeters. Therefore, the distance of between the chord and the center of the circle is 5 centimeters. In a circle of radius 5 centimeters, there are two parallel chords of length 6 centimeters and 4 centimeters. What is the possible maximum distance between them? In our figure, we have the two parallel chords 6 centimeters and 4 centimeters. The possible maximum distance between them, or dm, and the radius 5 centimeters. Since the dm is perpendicular to the two parallel chords, it forms two right triangles. We will label the opposite sides as d1 and d2. To solve this problem, we will be using the Pythagorean Theorem. And since the distance bisects the two chords, 6 centimeters will become 3 centimeters. That would be one side of our right triangle. The 5 centimeter radius is our hypotenuse, and d1 is our opposite side. Using the Pythagorean Theorem, d1 squared is equal to 5 squared minus 3 squared. 5 squared is equal to 25, and 3 squared is equal to 9. So d1 squared is equal to 25 minus 9. 25 minus 9 is equal to 16. d1 squared is equal to 16. To get d1, we will square root 16. So d1 is equal to 4. For our second right triangle, the 4 centimeter chord will become 2 centimeters. The 5 centimeter radius is the hypotenuse, and d2 is the opposite side. Using the Pythagorean theorem, we will get d2 squared is equal to 5 squared minus 2 squared. 5 squared is equal to 25, and 2 squared is equal to 4. So d2 squared is equal to 25 minus 4. 25 minus 4 is equal to 21. So d2 squared is equal to 21. To get d2, we will square root 21. So d2 is equal to square root of 21. dm is equal to d1 plus d2. Substitute, dm is equal to 4 plus square root of 21. So the possible maximum distance between them is 4 plus square root of 21 centimeters. A quadrilateral is inscribed in a circle if the measure of two of its angles are 65 and 145. What are the measures of the other two angles? Note that a quadrilateral is said to be inscribed in a circle if all 4 vertices of the quadrilateral lie on the circle. As shown in the figure, the yellow dots are the vertices of the quadrilateral. This quadrilateral inscribed in a circle is known as a cyclic quadrilateral. Now, let's name our angles A, B, C, and D. The inscribed quadrilateral theorem states that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Therefore, angle A plus angle C is equal to 180 degrees, and angle B plus angle D is equal to 180 degrees. Substitute, 65 degrees plus angle C is equal to 180 degrees. Transpose 65 degrees to the right side. Angle C is equal to 180 degrees minus 65 degrees is equal to 115 degrees. 145 degrees plus angle D is equal to 180 degrees. transpose 145 degrees to the right side, angle D is equal to 180 degrees minus 145 degrees. Angle D is equal to 35 degrees. The measures of the other two angles are 115 degrees and 35 degrees. If segment AB is the diameter of a circle with center P, and X and Y are points of the circle such that segment XY bisects angle AXB, then what is the measurement of angle AXY? In our figure, we have segment AB as the diameter and center point P and points X and Y. In this problem, we will apply circle theorem to angles in a semicircle. Angles formed by drawing lines from the ends of the diameter of a circle to its circumference form a right angle. Therefore, our angle AXB is equal to 90 degrees. Since segment XY bisects angle AXB, then angle AXY is equal to 45 degrees.